Here's my explanation for quiz 3, question number 1. My name is Erin Humphrey. Let's see. The water flow is surrounded by atmospheric pressure, so the pressure at control surface 1 is equivalent to the pressure at control surface 2, which is equal to 0. And then we are going to ignore viscosity and surface tension, just because at a certain fluid rate viscosity is negligible, and surface tension at a certain pipe diameter is also negligible, so we can ignore those in this particular equation. And then our control volume is not moving, so we're going to also state that the change in velocity with respect to the change in time is 0. So we have the RTT problem listed here, and then we plug in the values for velocity, which is equivalent to the flow rate over the area. So we have velocity twice, and then the normal is the area and then the direction in which it flows. So you plug in all the values, and then I retrieved these values for I and J, and then I found the magnitude, which is equal to 31,633 newtons. So that's the force, total force for problem number 1, and I think this case on the quiz has the most force on the pipe. And then for number 2, again, the water is subjected to atmospheric pressure, so at both control surfaces the pressure is 0. And then it was stated that we can disregard gravity and velocity, and since our control volume is moving, I left that in the Reynolds transport theorem equation, and then I just plugged in the values for velocity and then the normal surface, and then I calculated at which angle it seems that the forces would be greatest, and I think that at angle pi over 2, the forces, the magnitude of the forces in the x and y direction are the greatest. And then if the water flow and blade move at the same velocity, then the force on the turbine system would be 0.